This is Michael McDonald, Grace Griggs, and Ryan Sojak from Team Wingardium Furiosa. This video covers the team's process and results of building a machine to compete in the Fall 2018 ME 2110 competition. The goal of the machine is to score the most points against 3 other teams in the arena. The arena is divided into 4 home zones and a central platform called Azkaban. Points are gained by doing the following tasks: remove Dementors from the home zone, collect shiny objects, avoid Nifflers, and imprison Grindelwald in Azkaban. A planning tree was created listing all tasks necessary to complete the project. It was used to make the responsibility matrix and Gantt chart. The job responsibility matrix illustrates the essential tasks to complete the project and the degree of responsibility each member carries. Similar primary task responsibilities were given to the same team member, and the number of each type of responsibility is evenly distributed between team members. The Gantt chart presents a timeline for completing the project under the specified deadline. Due to the compressed nature of the timeline, the designing, prototyping, and testing of each subsystem were scheduled concurrently. Another factor considered in scheduling was the weeks in which the team members would have less time to dedicate to the project. The House of Quality relates customer needs and engineering requirements. Customer needs are divided into 5 categories: functions, no disqualification, human factors, safety, and miscellaneous. All needs in the no disqualification category were given an importance rating of 10 out of 10. Other important needs are machine safety, consistent performance, and scoring well. Important engineering requirements needed to address these needs are structural strength, deployment speed, and weight of moving parts. An excerpt of our specification sheet is shown here. Some specifications are drawn from the competition rules, such as the total cost of the machine, and others are created by the design team, such as the maximum amount of time it takes for the machine to fully deploy. This function tree shows the functions and subfunctions needed to score points. There are 4 main functions: navigate to the competition arena, move Dementor, sort Nifflers and shiny objects, and imprison Grindelwald. Each of these have subfunctions which were used to generate the morphological chart. The morph chart was used to generate many different solutions for each subfunction. These were used to create a diverse selection of alternative concepts which can be compared with the final design. The highlighted solutions were chosen for the final design.
3 alternative designs were developed based on popular ideas seen in opponents' machines. These include a system largely powered by gravity, a siege tower that moves into the center on wheels, and a scissor arm-based system. The final system addresses each task with a distinct subsystem. It uses a pair of drawer slides to transport the Nifflers and Shiny Object subsystem, the Dementor subsystem, and the Grindelwald subsystem to Azkaban. The system extends via a pair of pneumatic cylinders and egresses via a motor. These are the only actuators in the system, and there are no mechatronic sensors. A dislodging arm uses friction to roll the Nifflers out of their nests. Another arm then sweeps the Nifflers and shiny objects into the sorting box. Shiny objects fall into the sorting box, while Nifflers roll off the top and into another team's home zone. The direction of the box is reversible, which allows the team to gauge the defenses of machines on either side and then send Nifflers into the zone of a machine without defenses. The Grindelwald subsystem consists of a tennis ball housing attached to a primed mousetrap. After the machine has run for 27 seconds, the motor pulls a string attached to the release pin. This fires the mousetrap, imprisoning Grindelwald. The motor continues to run, pulling the pin and egressing the whole system. The Dementor subsystem consists of a hinged arm that drags the Dementor as the system egresses. At the end of egress, the Dementor is out of the home zone. Each design concept was rated on how well it satisfies each of the customer requirements from the House of Quality. These ratings were collected in this evaluation matrix. As seen here, the final system outperforms the alternatives in all categories except for Defends Home Zone. This negative is offset by the fact that it scores better in the more important criteria: performs consistently, addresses all tasks, scores well, and reliable triggers. As seen here, the final system scored highest out of all concepts developed.
Round 1 demonstrates an example of how unforeseen situations can affect performance. As seen, a Niffler is sorted by the arm but is trapped between the arena and the machine, causing the entire system to move. This results in the Grindelwald and Dementor subsystems being moved out of position as well, leading to a 3rd place finish. In round 2, the Niffler and Shiny Object subsystem performed as intended and collected enough shiny objects to result in a 1st place finish within the round. The adjacent team did successfully imprison Grindelwald by using a sensor. However, their shiny object subsystem did not score enough points to win the round. During setup for round 3, the team utilized the adjustability of the shiny object subsystem to counteract the height difference of the track. This adjustment allowed the machine to advance based on points from the shiny objects, like in round 2. Because there were so few ways to score points, the reliability of the shiny object subsystem was crucial to the team's success. Round 4 shows the first offensive application of the Niffler sorting box. Because the team to the right had defenses, the sorting box was flipped so that Nifflers were sent into the zone to the left. In addition, a successful imprisoning of Grindelwald, as well as continued success of the shiny object system, ensured that the team advanced to the quarterfinal round. The quarterfinal round shows the first instance of failure in the Dementor arm subsystem due to fatigue. Although the arm did not fully expel the Dementor in previous rounds, this was the only round where it prevented egress. However, due to the performance of the shiny object subsystem, the machine collected 6 out of the 8 shiny objects, leading the team to progress to the semifinals. In the semifinal round, the machine performed comparative to previous rounds. The shiny object subsystem functioned reliably, but was not able to interact with enough objects to receive an advancing score. This was compounded by a fatiguing Dementor subsystem and a lack of defenses. Although the team did not advance to the finals, Wingardium Furiosa did get 3rd in the round and placed 5th out of 59 teams overall in the competition. By the careful use of problem understanding tools, the team was able to have clear ideas on what to focus on. Based on its potential to score points, the Nifflers and Shiny Objects task was given high priority in development. Another focus was on avoiding the many opportunities for disqualification during the competition. This paid off in the final competition as the team did not disqualify, and the points scored from Shiny Objects were the primary reason the team advanced to the semifinals. If we were given more time, the team would improve the Dementor subsystem and add defenses, as these were the main pitfalls experienced during competition. Additional testing of the Dementor system might have exposed the faults in the design that led to it being non-functional during the final competition. During the course of the project, the team improved teamwork and time management skills, as well as learned how to carry out the engineering design process from start to finish. Thank you, Dr. Dinar, and thank you to our TA Omar for teaching this class, and thank you for listening.